Good morning. In this video I am going to discuss about the mechanism of SN2 reaction. So in SN2, 2 stands for bimolecular, 2 stands for bimolecular, N stands for nucleophilic, and S stands for substitution reaction. So that SN2 reaction is nothing but bimolecular nucleophilic substitution reaction. So let us see what is meant by bimolecular nucleophilic substitution reaction. Okay. So in this reaction, rate of the reaction will depend upon the concentration of two substances. For example, here actually we use two reactants. One is called substrate, which is nothing but an alkyl halide. The other one is nucleophile, which is provided by alkali. Rate of the chemical reaction is depending upon concentration of both the substances, that is alkyl halide substrate and the nucleophile, which is formed from alkali. So the rate depends upon concentration of two substances, so that this is called as bimolecular nucleophilic substitution reaction. Now the rate law for this reaction can be written as rate equal to rate constant K2. So bimolecular reaction rate constant, or rate constant of a bimolecular reaction. So that is rate law is rate equal to rate constant K2 into concentration of alkyl halide and concentration of nucleophile. So here the rate is depending upon concentration of two substances, so that it is a second order reaction. So second order, it follows second order kinetics, and it is a single step process, and this process SN2 reaction occurs in one step. Okay, right. So now let us see an example followed by the mechanism. So now I am going to discuss the mechanism with reference to a primary alkyl halide. Right, so this was the reaction CS3Br. CS3Br, which is nothing but methyl bromide. CS3Br is nothing but methyl bromide on reaction with sodium hydroxide. On reaction with sodium hydroxide gives methyl alcohol. The product formed here is nothing but methyl alcohol or methanol with byproduct sodium bromide. So here what is happening is the nucleophile OH minus ion, which is formed from the alkali NaOH, will come and substitute Br minus nucleophile. That is how it is a nucleophilic substitution reaction. As a result, you are getting an alcohol called methyl alcohol. Is that right? Now let us see how this reaction takes place with mechanism. Okay, right. So now this is nothing but CS3Br, methyl bromide. Now this is the nucleophile OH minus ion. Now the nucleophile attacks the carbon, which is bearing bromine atom, back to the bromine atom. That is, nucleophile attacks carbon atom back to bromine atom. So this kind of attack is not possible. That OH minus nucleophile cannot come and attack the carbon atom same side of bromine atom. Okay, the reason is here Br minus and OH minus both are nucleophiles. Nucleophiles are nothing but electron rich species, isn't it? So when two nucleophiles approaches each other, when they come nearer, so due to electron rich nature, they will repel each other. That is the reason why the OH minus nucleophile attacks the carbon atom backside of the bromine atom. Okay, so as to reduce the repulsion. Okay, so this kind of attack, what do you call it as backside attack? This type of attack is called backside attack. That is attack of carbon by the nucleophile opposite to the bromine atom. Okay, right. Now, so this will lead to a unstable transition state. So this is unstable transition state in which you can see that CBr and COH bonds are partially formed, isn't it? Or otherwise you can say that CBr bond is partially cleaved, COH bond is partially formed. And this three-dimensional, it has three-dimensional geometry in which that three carbon hydrogen bonds, this three carbon hydrogen bonds are lying in same plane, whereas this CBr and COH are just perpendicular to each other. For example, if CBr is just above the plane of that CH bonds, then COH will be below the plane. CBr is just above the plane, COH is just below the plane, whereas the three CH bonds are on the horizontal plane. Okay, right. So now, at last what will happen is that Br will go out as Br minus by taking the bond pair electron, whereas the OH minus nucleophile will complete the bond with carbon by sharing its electron, so that the COH bond is completely formed, which results in formation of the product methanol. Right. So this is what the mechanism of SN2 reaction. Okay, right. In transition state, COH and CBr bonds are partially bonded. CBr bonds are partially bonded, or otherwise exactly if we say CBr bond is partially cleaved, COH bond is partially formed. Okay. So at last COH bond is completely formed, CBr is completely cleaved and giving the products. Okay, right. Now here the important point what you have to note down is inversion of configuration occurs. What do you call it as Walden inversion? So what is meant by inversion of configuration? In the sense, suppose in this SN2 reaction, if you use an alkyl halide of D form, dextro form, an optically active dextro form, due to the backside attack, the product formed will be a LAVO form. So L form, and vice versa, or otherwise if you use alkyl halide of L form, the product formed will be a D form. Okay, right. So this kind of, so that we are getting an opposite configuration of the reactant what we have taken. So that's why that's what nothing but the product formed is having a configuration inversion of the reactant what is taken, which is called as inversion of configuration. Okay, so let us see one example for that. So this is nothing but an alkyl halide, a secondary alkyl halide, which is nothing but 2-bromo-octane. Okay, right. Now here the OH minus ion is attacking the carbon atom which is bearing bromine atom. Backside of bromine, as we discussed earlier, backside attack because of electron repulsion between the two nucleophiles OH minus and Br minus. Okay. Actually here we are taking a LAVO form of 2-bromo-octane. We are taking a LAVO form, an optically active L form of 2-bromo-octane. Okay, right. Now which leads to a transition state, so in which CBr, COH are partially formed, they are perpendicular to each other, and the carbon CH bond, then carbon bonds are lying on the same plane, isn't it, right? So the transition state finally will give the product which is nothing but 2-octanol. So this is formed after Br goes out as Br minus, then the OH minus ion completes bonding with the Br bearing carbon. Okay, and as a result we are getting 2-octanol. Now look at the configuration of 2-octanol. We are getting plus form of 2-octanol, otherwise dextro form. So we started the reaction with a LAVO form. Due to the backside attack, we are getting a dextro form, and vice versa. Suppose if you start with D form, dextro form, then the product alcohol formed will be a LAVO form. Okay, so this is nothing but the inversion of configuration takes place. Suppose the alkyl halide used is optically inactive, you get an optically inactive product. If the alkyl halide used is optically active, then only the inversion of configuration takes place. D form will give a product of L form, and L form of alkyl halide will give a product of D form. Okay, so this is what about the SN2 mechanism, what we call it as bimolecular nucleophilic substitution reaction. Okay, so very simple and very important mechanism. I hope you understood how this reaction occurs. Thank you very much.